Okay, now we will start the hands-on programming session, and I will start from like very, very basic coding. So right now I have a file open. It has nothing in it, so I will start from here. And so basically the first task, if those of you that are more experienced can go on, don't wait for me. You already try. So the task is to do this. So create a set of points distributed. You can either do 2D or 3D. It doesn't matter at this point because this doesn't really depend on the dimension, this very simple one. But maybe in the future, you will eventually want a 3D code, so you can start from 3D. What you want to do is create a set of points that have four attributes. It has X position, Y position, Z position to determine where it is in the space, and Q. So it has four variables, X, Y, Z, and Q. You need to create a set of points that have different X, Y, and Z values, and Q, you can have all ones, or you can have them different values, or it doesn't really matter. But as long as they're not zero, it's fine. So you can have any value of Q. You want to generate those points first, and you want to generate another set of points that have either a much larger X value, or much larger Y value, or much larger Z value, so that it's far away from these set of points. Once you have these two boxes, you first want to calculate the center of the box. So if you already have a plan on what your coordinates are going to be here, then maybe you can distribute your particles around point 0, and then say that the center of the box is at 0. And for this one, you can distribute all your points around 5 or 10 or something, and then say that your box is at 5, or the center is at 5, 0, 0, or some location in the 3D space that is close to these points. Once you have that set of points, you want to calculate the sum of Q, all the values, and say that that's the Q here. And then you want to take that Q and calculate this equation here, which is, so you need to take the distance in each direction. So if you had xi minus xj, and yi minus yj, zi minus zj, each of those components you need to use to calculate the distance. So from that you can calculate the distance r from each of the coordinates, and then you divide q by r to get the u value at this point here. And then you just assign the u to all the points. Oh, maybe I should use the stick. Yeah, so you calculate that to use the point to assign the values to all the points here. And then you need to do an extra calculation to check your answer. And that calculation, you need to loop over all these points here, loop over all these points here, and try to calculate the ui. For all the ui's, you want to calculate the effect from all the j's. So it's a double loop, looping over all the I points, these are the I points, to get all the ui's from the effect of all the uj's. Okay, so since the points are far away, this distance will never be 0, so you don't have to worry about 0 divide or anything like that. In the future, when you start to calculate the whole domain against the whole domain, you will have to worry about the case where you're calculating for the same point, because when I equals j, this distance will become 0, and if you divide by 0, this number will be infinity, and you won't get an answer. So you'll have to worry about that in the future. But in this case, don't worry about that. The points are always far apart. So this will never be 0. Okay, so just loop over all the points against all the points and get the ui. compare that UI against this UI. You can either print all the numbers and see what they look like, or you can take a more, like a mathematical representation of, take like the norm of the difference, so subtract all the values for each I, subtract this U from this U, and then, take the square of that and sum up all those squares and take the square root at the end. That will give you like a standard deviation of the difference between the two. And if that number is large, then that means the error is large. You can divide that by the absolute value of U so that you'll get a relative norm error. But anyway, you can calculate the error of this approximation. And an interesting thing to do once you've done that is to change this distance, make them very close and see how bad the accuracy gets. Make the distributions far and see how good the accuracy gets. So first, we will do that first, okay? You can ask questions anytime you find something strange, or I won't be making any mistakes on purpose, but I might still make mistakes. So tell me if you see something wrong on the screen. And okay, so I will proceed with the coding, and you can follow, or you don't have to wait, but you can actually confirm by checking your code with mine. Okay. Okay, so maybe it's you have like a maybe I can put it here. Okay, so I'm just going to add, basic header files because I'll be doing standard lib and maybe I'll add math.h. Okay, these are just including header files. Okay, now I'm going to write the main function. Well, just to check if your environment is working. Yeah, why don't we write a hello world for those of you who haven't been programming for a long time? Yeah, that's okay. Yeah, I'll just do it like this. Okay, so let's see if this works. Oh, it's fine. Yeah. Okay, so let's try to compile. So the name of the program doesn't really matter. I just named it step1.c. Okay, it compiled. Now I'm going to run it said hello. Okay, so well, I'm sure everyone can do this one, so I won't go around to check this one. Okay, so now let's generate a set of points. Okay, so let's generate 10 points. Okay, so we have x, y, z. I'm just creating arrays for create x, y, z, and q. Okay. So now I'm going to loop over from I to n. Yeah, why don't I actually print what I'm writing? So I'm going to say xi equals, let's say, some random number. So I'm going to use a random number generator here. that generates a number from 0 to 1. And I'm going to print that. Okay, just so I don't disrupt whoever is looking at my screen, I'm going to split my screen. On this side of the screen, I'm going to try to compile what I just wrote. Okay, so you can see what I'm coding. So I'll be switching between these two screens and adding more things. But just for those of you who don't know, who have. Oh, thank you. Okay, yeah, thank you. So if you've never used this DRAN 48 thing before, this is I've printed so that you can see what it's doing. It's generating some random numbers between 0 and 1. So you don't have to do the standard RAND thing generates an integer and you have to divide and do things, and this one is much more useful. So I'm using DRAN 48 to generate a number from 0 to 1. Okay, so now I'm going back to this side of the screen and going to do the same thing for Y and Z. So DRAN 48 and DRAND. Okay, and by the way, I'm using the editor Emacs, but you don't have to. You can use whatever editor you want. Oh, okay. And so just to explain everything I'm doing for, people with different levels may not know certain things I'm doing. So this printf LF means double. So if I wanted to print a float, I'd do %f. If I want to print a double, I do LF. And I'm going to print X, Y, and Z, all of them now. Okay, so I'm going. So now I'm printing X, Y, and Z, 10 numbers. So these are my X, Y, and Z. Okay. And maybe I'll generate Q as well. Q, let's see, I'm going to make it all ones because it's easier to check if they're all 1. The sum should be 10, and it's easy to check if it's correct. So I'm just going to make them all 1. And, oh, okay. I forgot to add another LF. Okay, at some point I'm going to go around checking if everyone is okay, but right now I'm just going to go on and create the second set of points. So let's say I'm going to do I'm going to create xi, yi, zi, qi, and like a second set of points that will be far away. So I'm going to call them xi, yi, zi. So I'm going to use two different variables for the. Okay, so let's call these qi
And now let's create a second set of points, xj, yj, zj, and qj. Well, actually, for one of them, I don't need the q. Let's say for the I don't need the q. Let's create ui, and ui can be initialized to 0 or something. Okay, so now everyone should have random x, y, and z for I. Okay, now, but this is not good because I needs to be far away. So I'm going to add some number here. Let's do like 10 or something. I'm going to add 10 to xi so that it gets shifted far away. Okay? Okay, so now we have all the set of points we need. We will do the first calculation. Let's loop for let's use j just to be consistent with the, I'm using j as the loop counter, so it's easier to see the correspondence between the lecture. Okay, so I'm going to create a new point. So let's say xj prime I call qjp. Okay, so I do need to create a new set of points. So let's say xj prime, yj prime, zj prime, qj prime, and also the xi. Yeah, I need to create for both I and j. Oh, sorry. I prime. Okay, I created all these different values, and let's say, so since I'm using a random number generator from 0 to 1, the center for these boxes we should know. So xjp I think should be at 0.5. Well, actually all of these things should be at 0.5. yj prime, zj prime, and for the I, only xip needs to be like 10.5, and yip and zip are still 0.5. Because I shifted xi 10, so the center of the box should be shifted 10. Okay, now I'm going to do the summation. So I'm going to start with qjp equals 0, and then I'm going to add all the qj's. So qj, j. So this will add all the qj's into qjp. Okay, this is step 1. Maybe I should write it somewhere. So this is step 1 in the slides. It adds all the qjp. Maybe if I have enough room in my screen, I can show. Yeah, so step 1 was to add all the qj's. So that's what I'm doing, and adding them to qj prime. Qj prime is not an array because there's only one number, 1 point. So it's just one double, not an array. Okay, now step 2. we need to calculate ui prime from qj prime divided by, yeah, so to calculate the distance, maybe we should create some more variables like dy, dz, and r. Okay, so what I'm doing here is I'm trying to form dx is the distance between dip minus, oh sorry, xjp dx dy dz dx dy dz, like this. So I'm calculating the individual distance in each direction, and then from this I can determine from the square root of the, like square, square, square. Yeah, so this is the definition of the distance, right? It's the square root of the distance in the x direction squared, y direction squared, z direction squared. So this is how I calculate r. And then I just divide by that r. This should be step 2, calculating uip from qjp. Okay, now step 3 is just saying I loop over I to all endpoints and say that ui at point I is equal to uip. Okay, this is step 3. UIP we just calculated in step 2, so we just now substitute that to all the UIs. Okay. And now we need to check the answer by looping over all the points. So I goes from 0 to n minus 1, and we have another loop that goes from j 0 to n minus 1, and we need to calculate the ui. Let's call this ui direct or something, uid. Okay, so uid, we just calculate that original equation. Okay, so again I'm going to use the dx, dy, and dz. Dx equals xi minus xii xjj dx dy dz is like this: x dy dz equals xi minus xj, and then I'm going to use this definition of r again. And then now it's easy. I just need to divide by r like this. And this is each of my UIDs, and the sum of all of these should match. So now let's do a print and see if these two numbers, how close they are. So what I'm going to do is I'm going to print UI that we calculated through the 3-step procedure, and I'm going to compare that with the UID that we just calculated with the direct summation of the original equation. So these should match. right? These should be the same number. So I'm going to shift back the screen. I'm going to keep showing this screen so that you can see, but I'm going to now compile on this side and see what happens. Oh, I think I forgot to define UID. Yeah, I had to do a declaration of the variable first. Oh, UI I also didn't define. Or no, I did define it. There seems to be some... Did I define UIP? Did I define... I defined UI up here. No. Ah, this one. Yeah, okay. Okay, this had to be UI. And this one too, I need to... Okay, now I think it's good. Okay, yeah, now it compiled. Okay, so now I see similar numbers. So what I'm comparing is this side. This side here is the one you get from the 3 steps. So they're all the same number because you just assume that they're all the same. But if the 2 boxes are far enough, the actual solution is, very close to all being the same anyway. So it's still a good approximation. They're separated by 10. So I shifted x 10. So this is like very far away. But so now, if I change the distance, then the numbers will start to become very different. And let's see. So this number I will change to maybe 5. I also need to change here to 5. Okay, they're still quite similar. So maybe I can do more. Why don't I just change this into a variable so that I don't have to change 2 places? Okay, so now I'm going to change this distance to 2, which should make the solution quite inaccurate. Yeah, so now you see quite some are like 6, 4, but the others say 5. It's somewhat like an averaged solution, but you start to see this big difference. Now 2 is still not the closest it can be. So we have from minus 0. We have from 0 to 1, and the other is starting from 2 and going to 3. So yeah, maybe this is the closest it can get. But so we want to improve this accuracy with high order expansions eventually. But for now, I think this is a good way to see how this approximation can work. So, it's roughly 5. We're getting a rough answer. That's roughly correct. Okay, so is everyone able to get this to work? It's
Local.
yeah. I guess maybe I went too fast. No. No. Are you able to log in somewhere? No.
We do not have to write the Linux language. So
Oh, okay. You want to use MATLAB? You have MATLAB. You can. Yeah. You can. Yeah, you can try to do it in MATLAB. It should be the same. You can do the same thing in MATLAB too. Okay. How? Okay. Oh, this is something else. Yep.
Show the code in the video.
Here?
Yeah. I think that step 1 and 2 is
Step 1.
1, 2, 3.
Step 1, 2, 3, like this. Okay. Okay, so I think everyone is coding something. Yeah, okay. Okay, I'll see. We have time, so I'll go slow. Make sure everyone is okay. Okay. Oh, okay. Okay.
London just also 0.
The London did not show any London.
Oh. What happened? No random? No, it shows 1. It's always 1.
I used 1 plus, but
Oh, it's showing 0.
yes.
Stand it. Oh.
Is anything wrong here?
Maybe it's like Ubuntu. Oh, that's strange. This is double. Okay, it's. Okay, so sometimes you need. So this is called a seed. So srand48 sets like a random number seed, and sometimes you need to set this for the generator to work correctly.
So if I need for B random,
No, you only just need to do this one time in the beginning. So it should be, yeah, sometimes you need to do this. Oh, okay, so I have some. Is everyone?
I will prepare the account for them.
Oh, they have account. Okay. Okay, yeah, let's.
Most of them can compile locally.
Locally,
in their own,
okay.
Computers.
But maybe some.
Maybe some need that.
Yeah. Here, okay. Yeah, maybe on this side I can show other parts of the code so that you can.
Okay, that's good.
So I can show a larger part of. So step. Maybe.
Certain people they include a math,
Mm.
large, but still they didn't get a square root.
Oh, really?
Do you have any idea? I think probably they haven't installed the
It's
library
math.
correctly.
Let's see.
如果你那个 square root SQRT 好像如果 include 进来的话，你来一下那个 server 账号，移到 server 上去问好不好？那你看看是不是你当初装的时候，或者用 ESQRT。
You can try square root f. No? Do you have it?
Square root f, not your s.
There's d square root. No.
No, they don't.
It doesn't work.
No.
You can try sqrtf.
Oh.
Sqrtf. There might be a sqrt.
Yeah.
No? No.
Interesting.
Do you have math?
Yeah, I think he did.
Okay. Cool. GCC. Oh, that's strange. Undefined reference to it. No, I don't know what's wrong.
Yeah. I think it's probably the how do I compare Chinese to no try to say 而且 LM 那个我那个卡帕里面是减 L 的。那个如果你卡帕不过的话，你 GCC 空一个 dash LM 的空格，然后 step 1点是 some old version.
Yeah.
They need to put the flag dash LM.
Ah, okay. Yeah. I see.
老师，你是说 dash
对 GCC 空格对，这是 L， 然后你要打那个 step 1的那个是。
还是
这是 B 还是
L？
没有用，工作站上才可以，工作站上需要打 LA，不然没有。
工作站需要打 L。
对
OK。
所以
他们就是有过，但是你可以过了。OK。那有的好像可以，有的不行。那如果不行，我再找。有同学到工作站上已经。
我现在是在我这台上面。
还是过不了。
对，我现在是我在自己的身上，所以我应该去用那个账号。
呀，那就用这个账号。
因为我自己跑不动，我跑不动啊。
账号有一张纸。
打在后面。
你说是打后面？
对。
好，那有。
那个不知道工作站密码的，工作站那个 IP 或者
要不然的话也有办法，就是说你先打这个。
So this problem is solved
Okay.
by using LM,
LM.
but there still use. But he used a server, so it's okay for now.
Okay.
所以你就可以的 OK， 要
我打在后面的可以。啊？我的副有没有在后面？
在后面。
这个工作站。就是对，直接把这个东西拿一下这里。
Oh, well, it's older. It's interesting. If you put a dash behind, then it's work.
Ah, yeah.
哎，那个玉阳，
哎，
那个
打在后面吗？
打后面。
OK，我试一下。
然后你的城市点4，然后空格。
Good. Okay. Everyone's okay. Okay.
我有 print 它，还是我关掉重开？知道吗？扣的哦。哎，等一下，我 X 扣。
但是你至少可以。
你让我看一下。对啊，我先传给你。在哪里啊？
好，那这边尽量做。
Okay. We should we continue or we can take a.
How many pencil session you plan to do?
So we can take a break and then continue until 1.
Yeah.
Yeah.
I think that's a good idea.
Okay. But
这样子为什么？
well, if everyone is finished up to here, then maybe I should continue now, so they have more time to work. Yeah.
That's also
Okay.
A 点奥是你如果要给改名的话，你后面要再多写下去。
哦，所以我是不懂意思。
好，那这部分还可以吗？好， 就至少有没有看懂老师做的？可以好，那我们就先继续好不好？好
Okay. So next is let's see. Okay. So now we are running just like this and seeing numbers for when they are far away. Okay, the next task is this one. So now we're just doing only like this one and this one, only one pair that's far. In the next one, what we want to do is divide the domain into many different boxes. Or actually what we can do is we can create this artificially. Like create a box that has from 0 to 1, 1 to 2, 2 to 3, and 3 to 4. And like create a artificial domain that looks like this one. And then what we need to do is we need to make the far pairs interact. And then the near pairs interact directly. So what would be the best way to do this? I think we can number the boxes. So the picture is in 2D, but actually we are now working in 3D. So you will have 4 by 4 by 4, 64 boxes. So you want to create 64 boxes, each with maybe 10 points. And then you want to calculate this thing, and then also calculate this thing. And the question is how to determine this box here, and how to determine these boxes here. So usually what we